Hey there, it's me, Miss B, and we are looking at the Unit 3, Lesson 3 Cumulative Practice Problems for Illustrative Math Geometry. So let's dive in here. We are talking about dilations in this assignment. So quadrilateral ABCD is dilated with center 0, 0, so at the origin, and that takes B to B prime. Now they want us to draw A prime, B prime, C prime, D prime, which means I need to find all of my other points, A prime, C prime, and D prime, and then connect the whole thing. So the first thing I'm going to do is kind of just mark that, yeah, my origin, that is my center. And we have to look at what sort of dilation we have going on with B and B prime. So I'm going to draw a line that goes through both of those. And you can see here, the original one here, the size from the origin to B goes up 1 and then over 3. And from the origin to B prime, it goes up 1 over 3 and then up 1 over 3 again. So this has doubled in length. That tells me my scale factor is going to be 2. So I'm not just going to be going up 1 and over 3 for each one because it's not a translation, but I am going to be doubling the length of each distance here. So if A, or my distance from A, goes up 1, 2, 3, and over 2, I can go up 1, 2, 3, and over 2 again to find A prime. So that would put A prime right here. We're going to do the same process for B, but I'll draw so you can see here. I'll kind of connect this, and I'm actually going to make little teeny tiny, I'm just going to make this so it kind of looks dashed, I guess. But it's real hard to make my eraser real small, so that's about as good as it's going to get. But now you can, I guess, kind of see that it's a dashed line. So let's find D. From our center D, I have to go down 2 and then to the left 3. So I'm going to go down 2 again and left 1, 2, 3, and I'll end up right here. So that is this point. That's going to be D prime. And I'm not going to draw that line in, but it is twice the distance. Let's just do C. I actually only go down 1 and to the right 1 for C. So we'll go down 1 and to the right 1 again, and that'll put C prime right here. Now I want the whole shape, so I have to draw the whole thing. I am going to connect all of my pieces together. You would do this with a ruler. I don't really have a ruler necessarily on my iPad. I just get to allow it to snap things to straight lines for me. So that's what I'm working with. And it may make things a little bit interesting later on, but that filled in shape is my new quadrilateral. So A prime, B prime, C prime, D prime. Okay, let's look at question 2. This one gets a little bit more complicated. Triangles B and C have been built by dilating triangle A. So that means triangle A is my original or my pre-image. So that is my pre-image. They want me to find the center of dilation. Now, I know that with my class, this was not something I specifically spoke about, but it'll probably make sense after I show you. So using a ruler, you would line up corresponding points on your figure. So I am going to line up my top corners here. And since I don't have a ruler, I have to allow my iPad to make this a straight line. And I'm going to extend this kind of as far as I can because I'm going to do this with all of the corresponding points that I can find. So now I'm going to do it in red for my bottom corners here and extend these, make my iPad snap it straight, and Yeah, that's going to actually be as close as it gets. And we do want to check we can actually do this with, I'll use a black line, I suppose, for the middle corners here. We want all of these to end up in the same place. And so even though, oh my gosh, well, it doesn't want to snap nicely to that, or I'm sorry, it wants to snap nicely to it, and it shouldn't be. But we would trace essentially these lines back to one point, and that is going to be over here on the very side of our paper, and that would be our center of dilation. So center of dilation, I'm just going to point an arrow at it and say it's there. Okay, now let's look at B, C, and D. They are saying triangle B is a dilation of A with approximately what scale factor? So they want to know what scale factor are we using to change A into B? So if they say B is a dilation of A, that would be A, meaning A is our pre-image. So in this case, these distances are going to be about 3 times the size. So I am looking at first my distance from the center to my original triangle A, and then the distance from that to triangle B. So if I do a little bit of iPad maybe copying, cheating magic here, I can actually copy my exact distance thing here and kind of paste it and paste some more of them and show that it's about 3. And I didn't have that like exactly in the right place, but we're going to say it says approximately, we're going to say approximately scale factor of 3. Now, if we did that the other direction, and we said A is a dilation of B, that would then make B the pre-image or the original. Which means that instead we are shrinking B down to A. So in this case, that would be the reciprocal or 1/3 as the scale factor here, because it is going to be 1/3 of the distance of, from the center of dilation as B is. And the last piece that we're really looking at is triangle B and triangle C, and approximating a scale factor here. So I am actually going to use the underneath part and maybe just sort of draw an approximation of where B lands. So I'm going to do some copying and some pasting. And this, it looks like it overlaps about halfway. Now I didn't draw it super straight, but it looks like about half of it overlaps. So if B, oh, I'm sorry, I started rationalizing this in my head before I even really looked at the order of this. This means that C is our pre-image. So we're really looking at, and sorry about that, C is our pre-image, which means that's our original. That's what I should be looking at, is the distance here from the center to C. So maybe we would highlight from the center to C is going to be pretty long. So C, we'll use green. This might be the whole thing. But then I'll use yellow, I guess. B is not going to be the whole thing. It looks like it goes about 2/3. So we would then be able to say that our scale factor here is 2/3. because it seems to me that if I cut this like here and here, the yellow one is 2 of those chunks and the green one is 3. So that's where my 2/3 comes from. Okay. Now let's move on to the back. So question 3. We're going to do a couple of things here. It's giving us a couple sets of instructions, but it won't be too bad. It's just practicing more with dilations. I'm going to try to use red here just so that it stands out a little bit more from a bunch of the black lines that are on this with the triangle. So draw the dilation of triangle ABC with center 0, 0 and scale factor of 2. And we're going to label this A prime, B prime, C prime. So with a scale factor of 2, we are still starting at our center. And then following, if C goes up 2 and over 2, we're going to follow that same pattern again, up 2 and over 2 to find C, the same way that I did for the first question. B is down 2 and left 2, so we're going to go down 2 and left 2 again. I'm supposed to label these the prime version, so C prime, that means this is B prime. And then for A, from the center, this is down 2 spaces and over 4 to the right. So I'm going to go down another 2 spaces and over 4 to the right, and that will bring me here. I'm going to label this A prime. Okay, so label this triangle A prime, B prime, C prime. Done. I'm going to just connect it so I have my big triangle. But I am not done with the whole question. I have more to go. But I am going to erase the center part there because I don't want it shaded in necessarily just yet. So that is my red triangle for me, just so that you guys can see that. You don't have to actually do it in a different color. I'm going to do this next one with blue. So we are supposed to draw the dilation with a center of 0, 0 and scale factor of 1/2. So that means that instead of going up 2 spaces and left 2 spaces, we only want to go half that amount. So we'll go up 1 and left 1 and put our point here. So my point for C double prime is going to be right there. Likewise for B double prime, instead of going down 2 and left 2, we're only going to go half that distance. We'll go down 1 and left 1. And for A, instead of going down 2 and to the right 4, from our center, we're going to go down 1 and right 2 and make sure we have half of our distance. So this is going to be B double prime, and this is A double prime. So I am going to connect this one, and I'll leave it sort of, I'll leave the filled in center for this one. Okay, so I have my 2 triangles. So that is going to be my blue triangle. Now the last question here says, is A prime, B prime, C prime, so blue triangle, is that a dilation of A prime, B prime, C prime, which is the red one? And if yes, what is the center of dilation and the scale factor? And the answer to this is yes. If they're both dilations using the same center of the same object, then as long as, we have different scale factors, but that same center, they would be considered dilations of each other as well. They're just going to have a different ratio. So we would say yes, center 0, 0, because we're using the same one. But now we're going to compare distances between our double prime and our single prime versions. Now, if they're asking this one as a dilation of the other, that means our red triangle is the original. So from this red triangle, we are getting smaller, which means I have to compare my distance here and see just how far it is. And it might be easiest to see actually with B prime or B double prime and B prime to the center here. So this diagonal cuts exactly It's over 1, up 1. It's got like a slope of +1 here. If our red triangle is the pre-image, this goes 4 units or 4 units up and over, where B double prime only goes 1 unit up and over. So this is actually going to be 1/4 of the size. So that is going to be our scale factor. This is 1 diagonal away, and this is 4 diagonal spaces. So our scale factor will be the image, which is our blue triangle, divided by the pre-image, which is the red one. So that's why we're going to get scale factor of 1/4. And that is question 3. For question 4, we have another situation, but we don't have a picture. It says triangle DEF is a right triangle, and the measure of angle D is 28 degrees. What are the measures of the other 2 angles? Show how you know. Well, let's draw a triangle because it says to show how I know. And if they don't have a picture, I am going to draw one. And they said it was a right triangle, so I'm going to make sure I draw a right triangle. And to do that, I find it easiest to put my right angle at the ground or between my vertical and horizontal. So we'll label this, I guess, D, E, and F. They told me that D was 28 degrees, and they want to know what are the other 2 angles. Well, you could have labeled it a little bit differently. So you might say F was the right angle. In this case, I'm saying it's E. So I'm going to say angle E equals 90 degrees because one of them has to be 90 since this is a right triangle. Now for angle F, this is going to be 180 because the whole thing should add to 180 minus the 90 and minus the 28. So that is going to be 90, 80, 70, 62. So 62 degrees. I have 62 and 90. And it's just some subtraction there. For question 5, we have a pentagon. So the pentagon ABCDE, or I'm sorry, A prime, B prime, C prime, D prime, E prime, is the image of pentagon ABCDE after a dilation centered at F. So I see F right here and right here. Got it. And then ABCDE prime, that is the green one on my image here, or it's just the larger one on the outside. I'm not going to outline the whole thing, but you can see I'm highlighting one that has the prime numbers or the prime letters in it. They want to know what is the scale factor of this dilation. So in order to find scale factor, we are going to take image and divide something from our image or our new one and divide it by something from our pre-image or our original. I think in the last one I called it copy divided by original, but same thing with image and pre-image. So the image here, I'll just use the segment that I highlighted. The image here, that has a length on that segment of B prime C prime of 10. So I'll actually write B prime C prime. And I'm going to divide this by BC, which is going to be my pre-image length. And the pre-image length here is 6. So 10 over 6, and I'm going to reduce this. This would become 5 over 3. And this is the scale factor of my dilation. You can check it with the other pieces as well, but I know that if my image is getting bigger, this is correct that I should have a larger number in the numerator and a smaller number in the denominator. Okay, let's look at question 6. So a polygon has a perimeter of 12 units. It's dilated with a scale factor of 3/4. They want to know what is the perimeter of its image and show how you know. Well, first of all, this can definitely be determined. I see that answer down there of it cannot be determined. That is not correct. But if it has a perimeter of 12, that is a single dimension measurement. So we are essentially going to take that perimeter and multiply it by 3/4. Because just like my polygons up here, in this case it's a pentagon, each of the sides is going to get dilated by that same scale factor. So what I'm going to do is say 12 and multiply that by 3/4. And you can consider this, you can divide by 4 and then multiply by 3, or you can treat this like a fraction, 12/1, and kind of go from there. But either way, you should get 9. And that means our answer is A, 9 units. Well, it's also definitely not going to be 12 because 12 would be staying the same and not really undergoing dilation at all. And 16 would be if we did 4/3 instead. So it is 9 units. And that work right there is how I know. Multiply it by that scale factor. So let's flip the page and keep going. We have 7, 8, and 9, but they're also not too bad. They're not asking us to write paragraphs of explanations. I'm just being long-winded. So triangle ABC is taken to triangle A prime, B prime, C prime by a dilation. Which one of these scale factors would result in an image that is larger than the original figure? Well, that is based on if my scale factor is bigger or smaller than 1. And in this case, if I want larger, that means I want something bigger. That is going to be 4/3. I'm going to say because 4/3 is greater than 1. That's my answer. It's just bigger than 1. Okay. Now for question 8, we're actually using a different center than we've used before for our center of dilation. We've used centers that are off to the side, and we've now used centers that are in the middle. But in this case, we're actually using D, a point on the quadrilateral itself, as our center of dilation, but they are saying scale factor of 2. So D is not going to move, but everything else, A, B, and C, are going to move further away from it. But I'm going to follow the same kind of idea. To get from D to A, I kind of go up one of these and then follow to the left. So if my scale factor is 2, I'm going to go up 1 and to the left, and then up 1 and to the left again, and it should be right here. So I will put a point right there. And this would be my A prime. A prime. Okay. Now for B, from D to B, it looks like we kind of go up straight 2 of these and then diagonally up right. So if we went up straight 2 more and diagonally up to the right, that would put me in this location. So that is going to be my point right here. I'm going to label it B prime. Then for C, this is just following one of our grid lines already diagonally up and to the right. So I'm just going to count how many little intersections it goes, or how many units it goes along here. It goes 1, 2, 3 triangles, which means I'm going to go another 1, 2, 3 triangles in the exact same direction and land with my point right here and call this C prime. Okay, now, did they want us to do anything with that? No, they just wanted us to dilate it, so I am going to draw this whole thing in. And you should see that each of your lines. Now I didn't draw that quite right. Here we go. Oh, it's not behaving nicely for me. But they should line up and go through each of these points. If I did a grid line accurately here, we would have, I can draw sort of an imaginary line of dilation through B prime and B and D here. So this would look more like this after we sort of dilate it. But yeah, that's what it would look like if we used one of our corners as our center of dilation. And I guess my side here didn't quite land where it should have. It should land right on the line. So I'll fix that up. Last question here is polygon P is polygon Q is a scaled copy of polygon P. So Q is the copy and P is the original, meaning P is the pre-image and Q is the image. So if the value of X is 6, what is the scale factor? So here is 6. We want to find our scale factor. We actually don't need to know the value of X in order to find our scale factor here. All we need to do is actually say what is our copy, or find a corresponding piece on our copy, and divide that by something from the original. So I'm going to use these numbers right here at the top. They're throwing 6 in there as a little bit of something to throw you off. You're not going to use 4 and 6. We're going to use something from one of our originals and something from our copy. So the value from our copy, which is Q, is 3. So this would be 3. And then 4 is the corresponding piece, so 3 over 4, which means that A is here. That is what I'm going to use as my answer. And if you really want to show even more how you know this works, you can say 4 times that scale factor, 3 over 4, should equal the equivalent or corresponding piece from polygon Q, and that is 3. That does work out if you checked it with a calculator. And that is all for this assignment. So this is the Unit 3, Lesson 3 cumulative practice problems for illustrative math geometry.